Intro music, upbeat, techie. Host energetic, facing camera, hey, everyone, and welcome back to the channel. Today, we're diving deep into the unsung hero of the self-driving revolution. We talk a lot about LiDAR, radar, cameras, and AI brains. But what truly unlocks the full potential of autonomous vehicles? It's their ability to talk, not with words, but with data at lightning speed. We're talking about autonomous vehicle communication technologies, the invisible network that will make our roads safer, smoother, and fundamentally smarter. Buckle up, visual split screen, modern car with sensors versus futuristic concept car networked with other cars and infrastructure. Host right now, most advanced driver assistance systems, ADAS and early autonomous vehicles are like isolated islands. They rely solely on their own sensors to perceive the world immediately around them. This works, to a point. But what about the truck around the corner? The traffic light about to change 2 blocks ahead? The sudden obstacle just over the hill that their sensors can't see? Yet, that's where communication comes in. It gives vehicles super sight. Section 1. Why communication is non-negotiable for true autonomy. Host, think about human driving. We don't just use our eyes, we use turn signals, brake lights, horns, and even eye contact or gestures. We communicate intent and share awareness. Autonomous vehicles need this too, but at machine speeds and precision. Here's why. 1. Beyond line-of-sight perception sensors have physical limits. Communication allows car A to see what car B's sensors detect far beyond its own range. Imagine knowing about black ice or a stalled vehicle miles ahead. 2. Predicting intent and coordinating movement. Simply knowing a car's position isn't enough. Is it about to change lanes? Brake hard? Turn? Communication broadcasts intentier. G, I'm merging left in 3 seconds, allowing other vehicles and infrastructure to react proactively and smoothly. 3. Enhanced safety through redundancy. Sensors can fail or be fooled, heavy rain, fog, glare. Communication provides a critical second source of truth, a shared understanding of the environment, making the system much more robust. 4. Traffic flow optimization. Imagine traffic lights that dynamically adjust based on real-time vehicle flow communicated to them, or vehicles forming tightly coordinated platoons on highways to reduce congestion and fuel consumption. This requires constant low-latency chatter. Visual animation showing V2V communication warning of an accident ahead. V2I communication with a smart traffic light. Platooning trucks. Host, so how do these cars actually talk? There are 2 main technological contenders vying for the standard. Section 2. The tech contenders DSRC versus C-V2X. Host, the battlefield for the communication airwaves, is primarily between these 2. 1. DSRC dedicated short-range communications. The veteran based on proven Wi-Fi standards IEEE 802.11p. How it works uses a dedicated band of spectrum, 5.9 GHz specifically allocated for automotive safety. Pros: low latency. Crucial for safety. Mature technology, relatively simple. Cons: limited bandwidth for future data-heavy applications. Shorter range compared to cellular options. Potential for interference in dense traffic requires dedicated roadside units RSUs. Visual graphic explaining DSRC spectrum and basic operation. 2. CV2X cellular vehicle to everything. The Challenger leverages existing and future cellular networks, 4G, LTE, 5G, and beyond. How it works: 2 modes. Direct mode, PC5 interface devices talk directly to each other V2V, V2I without going through the cell tower. Similar to DSRC, but using cellular tech. Crucial for low latency safety messages. Network mode U interface uses the traditional cellular network for broader range communication EA. G, cloud updates, traffic info. Pros: leverages massive cellular infrastructure investment. Higher bandwidth potential, especially with 5G, longer range via network mode. Clear evolution path with 5G, 6G. Better performance in dense environments. Cons: direct mode still maturing. Latency can be higher than DSRC if relying solely on network mode, though direct mode addresses this. Requires robust cellular coverage. Visual graphic showing CV2X direct mode versus network mode. Host, the race is intense. While DSRC had an early lead, CV2X, particularly with its direct communication capabilities, and the global push for 5G, is gaining significant momentum. Regions like China and Europe are heavily backing CV2X. The future might even see hybrid approaches, but interoperability is key. Section 3. What are they talking about? Key applications. Host, okay, they're connected. What messages are flying around? This isn't social media, it's high stakes. Standardized safety and efficiency data. Basic safety messages, BSMs, the core heartbeat. Sent frequently, eh? G, 10 times per second. Broadcasting core info location. Speed, acceleration, heading, vehicle size. This lets every nearby vehicle build a real-time map. Signal phase and timing. SPAT traffic lights broadcasting exactly when they will change. Your car knows if it can safely make that light long before you see it. Map data, mappy detailed local intersection geometry. Sent from infrastructure to vehicles. Roadside alerts, hazard warnings, ice, fog, debris, accidents. Broadcast by infrastructure or other vehicles. Cooperative maneuvers. Explicit messages for lane changes, merges, platooning requests. Intersection coordination. You go first, I'll yield. Sensor sharing raw or processed sensor data. G, I detect a pedestrian occluded from your view. Visual fast-paced montage showing applications. Collision warning at intersection. Emergency brake light warning, platooning, smart intersection. Navigation hazard warning. Host, this isn't sci-fi. Prototypes and pilot projects globally are demonstrating these capabilities, showing significant reductions in simulated collisions and improvements in traffic flow. Section 4. The hurdles on the road ahead. Host, the vision is incredible, but the road to ubiquitous autonomous communication is bumpy. Standardization war, the DSRC versus CV2X battle needs a clear winner or rock-solid interoperability. Fragmentation would be disastrous. Massive infrastructure investment V2I requires installing communication units RSUs on traffic lights, signs and roadsides everywhere. Who pays? Cybersecurity nightmare. A network of moving computers is a hacker's dream. Securing these communication channels against spoofing, jamming, and malicious attacks is paramount. A single breach could be catastrophic. Privacy concerns. Constant broadcasting of location and movement. Data raises big questions. How is this data anonymized, stored, and used? Spectrum allocation. Ensuring enough dedicated interference-free spectrum is available, especially as demand grows. The chicken and egg problem. Car makers hesitate to include expensive tech without infrastructure, and builders hesitate without enough equipped vehicles. Visual icons representing each challenge. Standards document with question. Mark, $signs, padlock shield, eye icon, radio waves, chicken and egg cartoon. Host overcoming these requires unprecedented collaboration between governments, regulators, automotive giants, tech companies, and telecom providers. Section 5. The future is networked. Host, despite the challenges, the trajectory is clear. Communication isn't just a nice-to-have for autonomy. It's fundamental for achieving the highest levels of safety and efficiency. SAE Level 45. Imagine virtually eliminated intersection crashes, cars and lights coordinating perfectly, traffic jams becoming rare, dynamic flow optimization and platooning, emergency vehicles getting instant green waves infrastructure, clearing their path automatically, new mobility services fleets of autonomous taxis, and shuttles operating with seamless coordination, smart cities transportation, fully integrated into the urban digital ecosystem, visual futuristic cityscape with smoothly flowing, autonomous vehicles, integrated with public transport and pedestrians. Host, the Internet of Vehicles is emerging. It's not just about cars driving themselves. It's about creating an intelligent, cooperative transportation system. The communication layer is the central nervous system making it all possible. Conclusion. Host standing, slightly more reflective. So the next time you see a story about self-driving cars, look beyond the spinning lidar. Remember the invisible chatter happening, or needing to happen, between those vehicles and the world around them. It's this communication technology that will truly transform our roads from chaotic, individual journeys into a synchronized, safe, and efficient dance of machines. The future of autonomy is deeply connected. Host, back to Energetic, what do you think? Is CV2X the clear winner? What's the biggest hurdle? Let me know in the comments below. If you found this dive into the invisible tech fascinating, give this video a thumbs up and subscribe for more deep dives into the future of transportation. Thanks for watching and drive safe. even if your car eventually does it for you. See you next time. Outro music, faidezinho. End screen with subscribe button. Links to related videos.